Hello, I'm Pon. I'm an artist, sorta, and a hobbyist game dev, and I want to make a game. The game I want to make is a single-player Eve-like, so no unscrupulous assholes laying in wait to gank your shit. Yes, I am bitter. I've always been a big fan of space and science stuff, and I have a lot of nostalgia for that internet finance simulator, so I guess I'm trying to capture what Eve felt like for me. Traveling, combat, resource harvesting, space trucking. You might think a project like this would be out of my league, and you'd be right. But I lose nothing from trying, and if anything, I'll come out of this with valuable lessons and experience. And to do this, we need an engine, so I've procured the best damned engine on the market. Godot! Before we start, this is not a tutorial, though I'll be going into some details on what I'm building in this video. If you're an aspiring dev like me, you might find something useful here. And a little disclaimer for the system I'm about to show you, I've built it before back in my Unity days, so we're not going into this entirely blind. The issue is adapting the work in Godot, but the principles are the same. So, we're going to simulate the solar system. The first thing I did was a flying camera, and despite having some experience with Godot, I still need to Google basic shit like how do I rotate a node. I also like to learn the rotation, it feels quite nice. Then we need a viewport container and two viewports, one for local space and one for scaled space. In real life, planets are much too big and far apart to put into our scene at full scale, so we're basically going to make a 3D skybox, hence why we need two viewports. We're going to use a scale factor of 1 to 10,000. 10,000 to 1? We add a camera to our scale space and have it copy our rotation, then our position times our scale factor. We have now successfully faked the scale of space. This is cool, but we're far from having a fully realized solar system we can zoom around in. This might get a little messy. Let's go back to local space for a bit. I'm gonna give my camera what the nerds call a floating origin. Basically, we keep track of our player's distance from 0, 0, 0, and if we go over a limit, we snap the player back along with whatever objects happen to be in local space. This keeps us from ending up too far, where physics and geometry get kinda wacky. Back to our scale space, we need something that can store massive coordinates with high precision, with double the precision if you will. This Vector 3D class, adapted to GD script from C# will help us in that task. I made a simple script called SpaceObject to hold an instance of Vector 3D other scripts can inherit from, though I'll probably not stick with inheritance. This scene I'm gonna go over quickly is like a solar system builder. Got a star here with planet children, and moons with planet parents. And all these have a scaled object script which hold this data here. Then up here we have a tool script with a nifty little inspector button that will calculate and set the position of our planets for us. God, I spent so long trying to gather the scaled objects with recursive searches. It's possible, I know it, but I couldn't crack it. Thank fuck for node groups. The math looks something like this. It's a lot of bullshit if you're like me and still have high school trigonometry nightmares. All it does is give our planets a position on an ellipse with modifications to the orbital plane for added spiciness. Then we multiply this by our orbit radius to get our simulated real position. We can now add this scene to our main scene and reference it in the Space Manager. What I want to do now is use our devcam as a reference frame around which we're going to move a scale space. Here we loop through the list of our planets and call this function that takes the Vector 3D position of our observer. And in this move position function we do this. It kinda looks like shit, but this is what it essentially does. You get the relative position of an object by subtracting your own position from its position. God, I miss the operator overrides. Doing this also means we don't have to move the scaled space camera at all. Wait, where's Ganymede? Where's anything? The math seems to work out. What the fuck is going on? I spent an embarrassingly long time debugging this only to find out I was using position, which is local space in Godot. In Unity, transform.position gives you the global position. You understand the confusion. This seems to work though. I can fly around and accelerate to absurd speeds to reach Jupiter, and Godot doesn't seem to mind its nodes being multi-millions of units away. With that said, where's Sun? Even somewhere as far away as Jupiter, stupidly massive objects like the Sun should still be visible. We're going to limit how far away planets can be from us, to somewhere within the camera's view distance. Ah yes, the Sun as seen from Jupiter. To fix this, we're going to use a trig. Going off this Wikipedia article, we find this formula that makes my eyes glaze over, which is supposed to give us the angular size of a circle. It's wrong. It's not, I'm kidding. We can simplify it though. We also need to take FOV into account. Then we can get the scale diameter and apply the scale to our body. And there it is, the mighty sun. So, why did we need to do all this? The reality is, most game engines are not designed to work with massive distances and scale. We lose precision pretty quickly the farther we go, and we don't have infinite render distance. And for the sake of transparency, I was working off ideas from the Kerbal Space Program devs in this Unite 2013 video. You should give it a watch, it's pretty cool. The next step will be flying an actual ship, which I kinda already done, but I also didn't want the video to go on for too long. So I'll save that for the next one maybe. I'm still not sure how I'm going to implement warp travel, so that might be fun to see how much I fail at it. I have a bunch of other ideas for other systems and mechanics I could go into the future, like handling stats and modifiers, inventory systems, mining, and so on. I hope this was at least a somewhat amusing watch, or that you find this interesting in some way. In any case, this is goodbye for now. Also, become a patron and pledge to my Kickstarter.